All right, before we go into chapter 7, I did fix this program up, okay? And I'll just take it and throw it out on GitHub or something if you want to see it. But there's still one error in it that I got to fix, and I'll fix that and then I'll put it out there. But I'd like to, just so you see it. So I come in here now, and I guess I should have centered that, but that's still okay. 23 and 12, add, subtract, multiply, divide, modulo, clear works. No, got setting that to the wrong thing, but clear works, and exit. Okay, so that all works. I'll have to check on that, but I'll put that out there. So let's jump into chapter 7. And chapter 7 in this book starts on about page 187, how to handle exceptions and validate data. And I've said this kind of thing before, maybe not in this class, but I've said it in the other class. I've got a 3.5-year-old granddaughter, and we've been pretty much in her life since she's been born. Now imagine she was just born and I'm taking her for a walk. There's a park that's fairly close to our house. So I'm taking her for a walk in the park, and somebody comes up and says, "Wow, what an exceptional child." All right, I'm probably going to say thank you. They don't mean, unless they say, "Wow, what an exceptionally ugly child," or an exceptionally stupid child, which typically people wouldn't say anyway, but you get the idea. The point is, in programming languages, exceptions are exceptions to the norm. They're not a good thing. So when an exception happens, it's a bad thing. All right. So we're going to talk about, as it says, how exceptions work, the dialog box that gets displayed with them, how you can use structured exception handling, and then validating data. Much of this is what we've already gone over. All right. And I want to mention this to you. I may have said this to you guys, either you guys last semester, or maybe I've even said it here already. But when it comes to trying to handle exceptions or problems in a program, there's 3 ways to handle it. First, you could do nothing and just assume that the person running the program knows what the hell they're doing. That's probably the worst way. I call it the ostrich method, how the ostrich sticks its head in the ground and, basically lets the world go on around it. So that's probably the worst way. But unfortunately, that's how some code is written. Then there's the way we've been doing it pretty much thus far, which is we let bad code into the system technically. So if I put, ABC in for number 1, but then I catch it with if statements, that's the second way. The third way is what's in this chapter, and it's by using what's called a try-catch mechanism. With a try-catch, what you end up doing is you end up doing something like this. You write the word try, and then in curly braces, this is code that may fail. That's not literally, literally that's code, but I'm just saying what happens again. Then you have one or more what are called catch statements. All right, and you say what to do if failure. All right, and if you want to, this is optional, you can put in what's called a final clause. We'll talk about what all of these mean, and that would be code in there in just a minute. The point is this. So I put in bad data in here, and it throws what's called like a number format exception. So it's expecting a number, you put in something non-numeric. Okay, so you got control over what you do in here. But what you can't do is say, hey, fix it, and go back up there then. There's no go-to here where you can do that. Yes?
So is it basically a risky if-else statement?
What it is there are books that you can read that will tell you that you really shouldn't use this, because what it's trying to do is it's trying to catch data before it gets into the system. All right. With some errors, it makes sense to do this. For instance, we have not talked about how you could save data like to a file. Okay. Let's suppose that we've got a program that we're running. Let's just say we've gone into files, and I've shown you how to create a file, and I've shown you how to read a file. Well, if you try to read a file, but you give it a wrong path, and the file doesn't exist, the program shouldn't continue on. You know what I'm saying? But with what we've been doing so far, if you put hello when it asks for number 1, I think we're handling it the right way, is what I'm saying. By running that validate method and then giving the user an error message and letting them try it again. All right. So to answer your question, what you typically see written as try catch blocks are code that if something fails, it's so detrimental to the program that quite often you don't want the program to continue. All right, does that make sense? And it just depends on what it is. I mean, if it's, after the break in here, so in April, we'll be talking about databases. All right. And a database is a way that you can save data. But if I say I want to save data to a database and I don't have permissions to use that database, then there's no sense in me going on because there's nothing I'm going to be able to do. I'd probably do that in a try catch. So again, it just depends. To me, I look at it as more a severity thing. And I don't know if that's what you were asking, but the more severe the possible error is, probably the better chance that you'll use some kind of a try catch mechanism. All right. Finally, they'll rewrite the future value application, and they'll do that using a try-catch mechanism. So let's take a look at what it says here. It says, a well-coded application will catch specific exceptions that might have been thrown and handle them. This is known as exception handling. Let's look at a program that doesn't do diddly for that. And I know that because I wrote it. All right, whoops, not there. So I'm going to bring up that calculator program again, okay? And I'm going to come in here, and I'm putting nothing in there. You'd agree with that? There's nothing in there. And I click plus, and the program blows up. All right, and what's it giving me? It's giving me a system format exception. It says that the input string was not in the correct format. All right, well, what the hell does that mean? Well, I mean, could I come in here and do something like this? Try. And I think this is going to work. I'm doing this off the top of my head, but I think it's going to work. But we're going to do it like this anyway. So I'm going to come in here and say this. In fact, I'm going to put them both in here. All right. And then I'm going to put in catch. Oops. Catch. Format exception. Usually you have to give it a name. FE, just FE for format exception. And I'm going to come in here and I'm going to say, how about this? Message box dot show error occurred \n plus, and I'm going to say FE dot message. Okay. And let's see, what else? What do we want here? I'm just going to say something like error, like that. All right. And I'll put in, because we've been doing this, our message box buttons. We'll just put an OK button in there and a message box icon. Oops. Try that again. With error. All right, so if there's an error, we're going to print it out. Okay, and then we're just going to return. In fact, let's not even do that. Let's say, let's clear it out. So let's say text box number, we're just going to clear both out. Number one dot text equals double quote, text box number two dot text equals double quote, and text box number one dot focus. And finally, this is inside of a void method. I shouldn't have to say the word return there, so I don't think that that's going to even matter, but I don't think it'll hurt anything. So let's try this. Now, I'm leaving it blank. Error occurred. Input text was not in the correct format. Okay, and I'm back there. But the program didn't blow up. That's the key thing. All right. So the bad thing is, what if I put in 12 and then I put in hello? The 12 is valid, correct? The hello is not. So still getting this, but now it removed them both. Well, that kind of stinks. All right. So how do I fix that? Well, let's look at how you'd fix that. It's not that great of a way, but it's the way that I would fix it. And that would be, I would come in here and do them as two different try-catch blocks. All right, so this would be number 2. 2, oops, 2, 2. Now we don't need this one anymore. And we don't need that one up here anymore. And we'd return. Now, we'll talk about how to make it even better in just a second. That's 1, 1. That's 2. All right, so now we've got this. If we leave it blank, okay, that handles number 1. If we put something non-numeric, still handling number 1. If we put a 23 in there, now it should be number 2. And we put junk in there. So that's not bad. Now we've handled it. All right, so I put in a 12, etc. You get the idea. All right, so, but one thing that we should be able to do in here is, I guess, we probably could at least take the message box part and put that into its own method. Like we were doing before with that print message box. We could do that. And we could save ourselves. So we could do some more modularization. I'm just trying to show you what's happening here. All right. So now our program is smart enough that it won't blow up if we put non-numeric data in it. So this is not a bad thing or a great thing or whatever, but remember, we'd fixed it before with that validate is numeric. I think that's a better way of doing it for what we're doing here. You may agree, you may not agree. There are all sorts of articles and stuff that you can read online where people will say you should use try-catch as little as you can, and do it the way that I've been showing you as much as you can. There are other people who disagree with that and think that you should use it when you can use it. It's a matter of how you were taught and what you believe, I guess. All right, so I just showed you that. All exceptions, as it says, are exceptions of the exception class. What the heck does that mean? That means that there's different types of exceptions that are in here. I just showed you a format. All right. Now, how about this one? I've actually put a check in here for this, so I'm going to comment it out. So I'm going to put in, where is that? All right, I'm going to save and run this again. I'm going to do one thing first, because I'm too anal about this stuff. And that is, those are all centered, and this one should be read only, and I didn't do that. All right. So when I come in here now, what happens when I do this? 23 and 0. Anybody have any guesses as to what's going to happen? I can add, I can subtract, I can multiply, right? What's going to happen when I press this? Anybody want to take a guess? Gives me infinity. It's trying to do it. That's not good. And what does this give me? NaN, not a number. Guys, remember that from JavaScript? All right. Now, it used to be, it would give you that error message. All right, you'd get that. So one thing we could look for in here is, I don't know, to be honest with you, but we'd have to check, so I will quickly. And that is, when we come in here and we look at all this stuff, we can catch as many errors as we want. So we could catch, is there a divide by 0 error? Divide by 0 exception. All right, so in that case, again, we'll come in here and we'll say the same kind of thing. But we'll change the message. All right, so we'll say here, illegal attempt to divide by 0. All right. And why is it giving me those errors? Message box. Oh, because the program's still running. Now they'll go away. There we go. So now, if I run it again, and it says there were errors. Great. Oh, I can't use the same name. I didn't give it a name. I used that FE there. But over here, I'm going to say DBZE, divide by zero exception. You can call it whatever you want. So this will have to be DBZE. That'll get rid of that error. It should. And I'm going to run it again. And now if I put in 23 and I put in 0 and I divide, I don't know if I put it in the divide or the modulo. Which one? Well, we're going to find out. I think I put it in that one. So let's try it one more time. Nope, it's not catching it. It's already done the math. So I'd have to check and see exactly what, how to handle that. I'd probably Google it, to be honest with you. All right. Technically, you could say, you know what, that's true, because anytime you divide something by 0, it is infinity. So you could say that that's actually working the way that it should work. All right.
So is this better than how we did the validation?
No. What I'm telling you is I only use this kind of stuff for stuff that could potentially kill the program. This is not that big of a thing. This is stupidity on the person running the program. You're asking them for a number, or you're asking them, I don't even know, like if I try my calculator on here, how about here? I don't even know what this does. Okay, that's probably what you'd want to have happen, would be something like that. All right. So I'll look into that and see exactly, because I know it's not that hard to change. The point is this, if you look up on the screen here, this is what's called a class in C#. There is a class called exception. And it has all of the different exceptions. How would I find those out? I would go out to docs.microsoft.com and I would search for C# exceptions. And somewhere in here, it's going to show me. No, it doesn't show me there. Let's try it here. Let's just Google it. Probably is in here. So look at these. These are all the different kinds of exceptions that can be thrown. Now, you're not going to write code that's going to handle every one of those. That would be a waste of your time, if nothing else. All right. But, to answer your question, Gabriel, is you'd have to figure out as a programmer, what could possibly happen that I wouldn't want to run the program anymore. That's all. And those are the kind typically that you do. For instance, if you're running out of memory on your machine, all right, or let's say that you're using a mainframe that's running out of memory. You're not going to be able to add memory to the mainframe, of somebody else's computer. So if that happens, you're going to want to quit. That kind of thing. All right. So if you look in here, notice there's different kinds of arithmetic exceptions. There's an overflow exception, and there's a divide by zero exception, and there can even be other ones. Then notice some of the things that can possibly throw exceptions. Well, guess what? These are ones that we've been using. Convert dot to double, convert dot to int, etc. Those are things that can throw exceptions. So we've been handling it by using that validate is numeric. What we're saying is you could also do it like this and then show this. Now, you may or may not have noticed, I'm going to come back and run this again. And I'm going to come back in here and I'm going to say hello and plus. Now, notice it says error occurred, input string was not in the correct format. Can everybody see this? I only said error occurred. The actual message that came after that, that was put in by this. You don't have to say that. You can put in your own message, but I like to include the system message because sometimes it provides more information than I've provided. All right? And that's why the error occurred, and I put a line break there, because then that's the system message that came. That's my message. That's the system's message. All right.
So it does look like this is way better than the validation we were doing before.
Well, what I'm saying is there are people who you can read articles that will tell you that if you want total control over your program, you should be using try-catches like this. Now, that's the good news. What's the bad news? Try-catches slow a program down a lot. And I mean a lot. All right. And they can almost, depending, like if you're doing a program and you're running it on your phone, they can almost stop the program. That's how slow they can be. All right. So again, they're great for errors that could have catastrophic effects on the program. I think they're overkill for other things. Not everybody agrees with that. If we had Mr. Gudmisted or Mr. Smith here, they might say, you know what, I respect what you're saying, Mr. Scott, but you're full of it. All right, but I'm teaching you the way I was taught it and the way I've seen it online, etc., the way I believe that it is. All right. All right. So I'm starting to already show you how to do this. Now, fortunately or unfortunately, all they're doing here is they're showing a message box and they're not doing anything else. That's silly as far as I'm concerned, because they're not even clearing out the field, etc. And I think you should do more than that. I think you should put your own message and then also put the system message. Again, not everybody agrees with that. I'm just telling you the way that I typically write it. So as they say here, you can use a try-catch statement to code what's called an exception handler that catches and handles any exceptions that might be thrown. In the try block, you put any statements that could throw an exception. And then in the catch block, you put as many catches in as you want. Now notice in here, they just put catch. All right, that's about as generic as you can make it. You don't want to write it like that. Because sometimes what happens, especially not so much in this language, but in Java, for example, because we'll go over this stuff again in your 4th semester when you're taking the Java class. But in Java, Java throws exceptions all over the place for stuff that, just because it says, oh, you didn't format this correctly or whatever. And it's like, that's tough luck. So I didn't format it correctly. So you can do this kind of thing in Java. You don't do this ever that I've ever seen. You typically give it a name in here like I showed you. Plus, let's say that I've got a bunch of different exceptions. And remember this? Where was that picture? Come on, where was that picture? There. If I want to check for both a divide by zero exception and I want to check for an arithmetic exception, I've got to list the more specific exception must be shown first, and the more general one must be shown underneath it. If I do it in this order, if I check first for an arithmetic exception, then I check for a divide by zero exception, since a divide by zero exception is a type of arithmetic exception, it'll never find that one. So when you're putting that in, you've got to be very specific. What does that mean? That means you got to do a lot of testing when you use try-catches as well. All right, to make sure that your program is acting and reacting the way you want it to act and react. All right. Properties and methods of an exception. I've shown you some of these. I showed you the message. Notice there's a stack trace. What that does is it shows you all the routines that were called up until this one. So you can work your way backwards to find out where the error might have been. All right, there's also a get type, which, as it says, tells you the current type of exception that's being thrown. So notice here, they're being a little better. Exception that's the most general one there is. So if you're going to catch exception, that has to be last if you've got a bunch of exceptions that you're catching. It must be last. Because it's so generic in nature, it'll catch everything. So in here, notice they put in the stack trace, the get type, and this is all the information you can get. That's the message like I showed you. And then there's more specific information if you want that. Now, is that overkill? It is, but if you're debugging a program and it's not working, it's not overkill. You might want to put it in there and then remove it later. All right, specific types of exceptions then. Notice there's a format, there's an overflow, etc. And as I showed you, the format is a more specific exception than the overflow, which is more specific than exception. All right. I mean, and just so you know, because some of you have asked kind of the same question, and it's an important question. I mean, should I use this? And I'd say for what we've been doing so far in class, no. That's my opinion. All right. But I was watching a thing yesterday. You've all heard this. Opinions are like butts. All right. The guy, he said a little more than I never heard. He goes, yeah, opinions are like buttholes. Everybody has one and they all stink. I'd never heard it put that way, but you know, so what I'm telling you is you could read another in your book or another article or talk to somebody else, and they might say, no, you should be using this all the time. All right. Now, then there's this finally block. And as it says there, typically the finally block is for performing cleanup. What does that mean? Again, we haven't done anything so far that requires cleanup. But if we had written a program where we had opened up a file and now we had a problem, in our finally block, we'd close the file. All right. And if we had a database that we opened up and we had an error with it, in the finally block, we'd close the database. Now, this is a great example, and I want to show you this on here. So you run this code. If this line here works, if this line here works, and this line here works, are you with me? If all three of these lines here for the try work, you totally skip the catch. You don't do any of the catches, but you do the finally. So now let's imagine we do the try and we've got a format exception. All right. Then we do this catch. We skip this catch. We skip this catch, but we still do the finally. Then we run it again and we get an overflow exception. We skip that catch. We do this one. We skip that catch and we do the finally. We do it one more time and we get a generic exception. So we skip that exception. We skip that exception. We do this catch and we do the finally. So what I'm telling you is you always do the finally. So you come in and you do the try. If there's no errors, it's like the catch never existed. All right. So also what happens, let's say in here, tell me if you're not with me, but let's pretend we don't have this exception, okay? So let's say we have only in here the overflow. Is everybody with me? We only have an overflow exception in here. That's it. Nothing else. Okay? We don't have we have a finally, but we don't have an exception. We don't have a format exception. We only have an overflow. Now we come through here and we get a format exception and we're not handling it. Anybody want to take a guess at what happens? It will crash, but before it crashes, it looks at the routine that calls this routine to see if that had something in there for a format exception. And if it doesn't find that, it looks for what call that. Eventually it gets to main. If it doesn't find it, it crashes. That's another reason that a lot of people don't like using try catch, because it'll end up crashing your program anyway if you don't account for everything that can possibly happen. All right. So you can throw your own exception. So imagine we were writing a real, I could write it right now, but we were writing a real simple program. Just draw it quickly on the board. So we're writing a real simple program. We've got here a thing that says MD. You'll know what it means in a second. This will say GU. That'll be a text box. That'll be a text box. It's for an MPG. So this will say MPG, and that's another text box. And here we have a calculate button, and we got an exit. We won't even worry about clear. All right. So if we put in 100 right here, and we put a 10 in right here, and we click calculate, we get 10. Everybody with me? That's fine. Problem is, what if we put in a negative 100? Now it's going to give us negative 10. All right. Well, would we really want to do that? We could handle it the way we've been handling it with if statements, and that's fine. But if we come in here, we want to handle it like this. We want to handle it with this stuff. Guess what? There is no built-in C# exception that says miles driven out of range. There isn't one of those. So what you can do is you can create your own exception. And then, so you could come in here and say throw, and typically you have them all in uppercase, and you'd say something like miles driven out of range, and you typically put the word exception on the end. All right, so you could throw that. And then you have to write the code to handle it. Do you understand what I'm saying? Then in your catch, you could have a catch for that. Okay? So you can write your own handlers. Now, one thing to realize, see this? You throw an exception. Singular, no S on the end. All right? C# throws exception, pluralized. That's not that important in this language, but it's more important in Java, so I'm just mentioning it to you right now. All right? Now, we're not going to go into the length and breadth of coverage of writing our own exception handlers in here, but we do it in Java. All right, so you will see this stuff again. So again, throw. So here's an example. Let's see. So they're throwing, and notice they're handling it right there. They're throwing a new exception, and they do something there. I don't know what. All right. So what they're showing, it says here, when a method encounters a situation that when it's not able to complete its task, that's when you can throw an exception. When you want to generate your own exception for your own exception handler, throw an exception. When you want to catch an exception, perform a processing, and then possibly throw the exception again. All right. I mean, what happens if you tell a person, hey, you put something non-numeric, and they put something non-numeric in again? All right. So it says you can use the throw statement to throw a new or an existing exception. All right. Typically, you use it to throw your own. So what they do at the end here is they go back in and they rewrite this, and notice it's in this big try-catch block. And they're saying, what can happen? Well, you can have a format exception. And if you do, you're just going to bring up that message box. You can have an overflow exception. So what's the difference between these? A format exception says typically it's expecting a numeric field and you put something non-numeric in. Does that make sense? Or it's expecting an integer, like the number of months, and you put a number with a decimal in. Those would both be format exceptions. What's an overflow exception? All right. It's something that you're giving us, the best example of this would be like, you ask the person their age. And I don't know if you remember this, earlier in the semester, we talked about making it a byte. And that byte would have a range of like 0 to 255 or whatever. And let's say you put in 1,000. That's an overflow. It's expecting something that's no bigger than this, and you're giving it something that's that big. It's the old proverbial trying to shove 10 pounds worth into a 5-pound bag. All right. And then they're catching a regular exception like this. All right. So then they go into how to validate. And again, much of this we've already covered. So what are they doing? It says code that checks that an entry has been made. So notice now they're doing it with an if statement. Now, what if, the good news or bad news, depending on your point of view, this works fine. That'll work just fine. And you can do that. You do an if statement. They're setting the focus back there, etc. And you don't have to get anything to clear it because there's nothing in there. So that'll handle that just fine. All right. And this will check for an invalid value. If you are writing a console application where you're going to ask the user to put in some information, are you with me? So you're writing a console application and you ask the user to put in their age. And they leave it blank or they put hello in there because they're a smart aleck. You don't want to use an if then, you'd want to use a while. You'd want to keep them in there until they put something valid in. All right? You don't put it in a while though, in that way when you're doing a Windows Forms app. You put it in as an if and you keep calling it again and again and again. So there is a little difference in the way that these are done. Ranges, these are the way we basically have been doing ranges. All right. So we've been doing data validation already. I put it in there. I'm just so you know. If you don't like this, I guess it's tough. But as far as setting cancel button, accept button, all that other stuff, I put that stuff into your test. That was not in your test because I wanted you to be doing validation and doing the right stuff from the get-go. All right. So it says there when a user enters data, the data typically needs to be checked to make sure it's valid. That's data validation. When it's invalid, you got to handle it. however you're going to handle it. Typically, just displaying an error message isn't enough. You typically want to display an error message that is not mean or offensive to the person running the program, but it lets them know what they did wrong. And you want to give them another chance. As it says, 3 common types of validity checking. Number 1, making sure some required entry has been made. All right. Number 2, make sure that if it's a number, it's a valid numeric format. And number 3, to make sure it's within range. And guess what? You've done all those already. All right. All right. To test whether a value has been entered into a text box, you can check the text property to see if it's equal to an empty string. We've already done that kind of thing. To test whether it contains valid numeric data, you can code an if that tests with a try parse. And with a valid range, it's with else if. Now, they're going to show this generic method to validate an entry. This is similar to what I showed you, but it's not the same thing. What I showed you, I think at least, was more concise. We basically just did this stuff. We didn't do the else. Well, we kind of did, all right, but we handled it back in our program. All I'm telling you is, look at what they've done. If what they've done makes more sense than the way I showed it to you, then use their way. I'm not ever offended, but when you're asked to do data validation, the assumption now will be made that, guess what? You're going to do data validation. All right? So they give examples. Again, this book is golden as far as if you forget how to do something, you're like, geez, I can't even find the darn program we did, then look in the book. Validating multiple entries. Well, notice how they're doing it. The thing about having multiple entries like this is totally fine. But if you're going to use try catch, did you notice when I had in the same try statement, when I had both number 1 and number 2 in there? The problem is either one of those can throw the error. And if I want to let the user know which one it was, I'm either going to have to provide more information to the catch or do it the way I did it, which is typically the way it would be done, is 2 different tries and catches. All right, so here it is when they've added error validation. So they're checking everything. So there's if you didn't put in an interest rate. There's if the investment was not a decimal, etc. You can read all those yourselves. I don't want to read to you. All right, and then they give you the code for this. Again, I'm showing you one way of doing it. The way they're doing it is pretty much the same way. All right, and notice it says in here, in this chapter, you learn how to handle exceptions and validate data so that you can code applications that are bulletproof. And notice that's in double quotes. No application is bulletproof. All right. And, the bottom line is until we've got computers in here, at least, that are different, you've always got the ultimate power, because if you get that ticked off, you can always turn the machine off. All right. At least you've got that going for you right now. All right. So before I put this chapter to rest, let's take a look at what our labs are for Chapter 6 and for Chapter 7. All right, so, So this is Chapter 6. We'll go over this stuff later. That's not a problem. So it says here, again, you don't have to complete those naming things. Number 1, write a GUI that contains an array. Well, that's the problem. That's why Mr. Gudmested is going over Chapter 8 before he did 6 and 7. Don't worry about this one. Anyone that asks for an array, you won't have to do it. We haven't talked about arrays yet. So we'll do this one, but we'll do it after the next chapter. With me? All right. So that's that one. Now I see why he's doing it in that order. All right. So this one, write a GUI program that determines the eligibility. Oh my gosh, another one of these. Okay, that has both a GPA and an admission score. Guess what? You've already almost done this. All right, but they're asking you to write a separate method to do it now. So I don't think that'll take you much time. The count vowels, didn't we already do that one as a class? All right, so just grab that one. the total area, this is going to be really similar to what you just had on your test, except what we're doing in here is we're doing the area and we're doing a paint estimate as opposed to a lawn thing. So you've done most of that. Write a GUI app that masks all but the last 4 digits of a credit card number. You ever done that? Where you go out to use PayPal or whatever, and it just shows you your last 4 digits? I'll let you think about that one. That one maybe we'll end up, even going over as a class. We'll see. Write a GUI app that estimates the cost of a custom-built desk based on these factors. All right, I'll let you read through that. Create a prototype for an online bank. I'd like you to try this one and just do what you can do with it. We will look at this one as a class because this is a more complex one. Plus, when we get to chapter 12, hopefully we'll be able to take this one and add object-oriented programming to it. All right, so that should be it. Make a digital version. Oh, this one we are going to do as a class. All right, I don't like their one that they've done, just so you know. So do I have that? I probably don't have it with me. Let's see if I do. I don't think I've got it here though. So do I? Let's see. Oh, looks like I might have it here. So let's see. That's the one we're going to write. Look on the screen here. So we can ask it a question. And right now, the reason this isn't working is it's a path thing because I'm running it from a different folder. We'll fix it. Okay, that's not a big thing. And then finally, the last one that you're asked to do in here. Get back to that and that. And I don't even know if you're asked to, I guess you're not asked to do it. It might be in the next one. But I want to show you the other one that we're going to do as a class. That's got to be here someplace. There it is. No, it isn't. All right, we're going to do rock, paper, scissors. And we're going to do that in a GUI. It's not in there. Is it? Do I have it? All right, I'll show you that after the break. I'll just quickly bring it up and show you what we're going to do. All right, finally, then for chapter 7. Hopefully you're noticing too, these programs are going to get more complex. All right. I still say, I don't believe there is such a thing as dumb questions, but when I had a young lady ask me years ago, are these programs going to get harder? That was pretty close. All right. Okay. BMI, guess what? We've done this one already. Ours, I think, is better than this. So you can use your BMI. And if you say, no, we haven't, we will take a look at it. Order with exceptions. All right. Take a look at that one. Decoder ring. Mr. Smith is into gaming and a bunch of stuff, so I'll let you take a look at that one. Basically, you put a message in, and it decodes it by putting it into something else. We'll talk about what that is. All right. Login exceptions. You'll make something like this for yourself. If you don't put in a right login and password, you'll get the error message. Okay? And these Build-A-Labs,